Welcome to the first lesson of the new unit. Our focus in this unit is over what's called a quadratic function. We are going to be looking at equations that now have, as you can see, x squared in them. These are going to be new graphs, new solving, all of that same stuff that we've done with lines, we are now doing with these new equations. So we are spending a couple of days doing a little bit of pre-work here over a topic that is called factoring. So let me explain to you what factoring is before we even get into how we do it. The previous chapter, we learned how to take problems that were in parentheses, like this, and we did a whole bunch of distributing. And we ended up with an answer. Factoring is literally going the other direction. I am going to give you the answer, and your goal is to figure out what goes in the parentheses. So we're going to take it in baby steps. The first day is going to be some of your easier problems. The second day is going to be a little more complicated. So we need to know some rules. Every problem that I give you is going to look like this equation right here. X squared plus bx plus c. Now b and c can be positives or negatives or any combination of. So our goal is to have some rules for how to find these parentheses. So this first slide is your important set of rules. How do we factor? Our goal when we factor is to find two numbers that multiply to give you c right here and add to give you b right there. Now, I will give you a heads up. If you are good at your multiplication facts, this will be much easier to you. If your multiplication facts are not so strong, talk to me. We can get you a multiplication list, at least to get you going. It's not something you could use on a test, but at least it would give you a base to start with. Now, in the process of trying to find these multiplication facts and addition facts, I had mentioned b can be positive, b can be negative, c can be positive, and c can be negative. So there's some rules that will help you in narrowing down your options. These are your sign rules, and as you can see here, these are rules that you must memorize. So here's our rule. If both b is positive and c is positive, then the two numbers that you're trying to find are also both positive. If b is negative and c is positive, then both numbers you are trying to find are going to be negative. Those are the easier rules. Now the little more trickier ones. If b is a positive, but c is a negative, okay, if you're trying to multiply to get a negative, there has to be one positive and one negative. Problem is, one of them is going to be bigger. In this case, the bigger number is positive because b was positive. Where if b is negative and c is negative, again, if your multiplying number is negative, then there has to be one positive and one negative, but this time your bigger number is negative. So that's going to take some time to memorize. Again, let me give you some ideas. When your multiplying number is positive, the signs are the same. Two positives or two negatives. And that decision is made by b. When your multiplying number is negative, there's one positive and one negative always, and the bigger one is decided again by b. These are some rules that we're going to come back to a whole bunch when we are doing factoring, something that you're going to probably flip back and forth to when you're doing your homework, but they will need to be memorized eventually for your test. So that being said, let me show you how this works. So the first thing we want to identify is our B and our C, or our adding number and our multiplying number. We are always looking for two numbers that multiply to give you C. That's the guy on the end. I put an M above him because he means multiply. And then finding two numbers that add to give you B. That's the middle guy. I'm going to put an A above him because he means add. Now, so we're looking for two numbers that multiply to give us a -8 and add to give us a -2. We're going to look at those rules we just talked about. If your multiplying number is negative, then we have one positive and one negative. Because our adding number is also negative, then the bigger number is negative. So in each pair, we have one positive, one negative, the bigger one's negative. Once you know that much, we can start writing down our work. We know that we're trying to work towards two sets of parentheses. The one thing that you will always have in every set of parentheses is an X here and an X here. Now, we just decided that we needed one positive and one negative number, and this negative number is going to be the bigger one. Now that we know all of that, the next step is focus on your multiplying number. My multiplying number is -8. I'm going to write out all of the possibilities that give me 8 when I multiply. Well, when I multiply to get 8, I could use 1 and 8. I could also use 2 and 4. And those are our only choices. Now, because we said the bigger number is negative, that means that is a negative or that's a negative. Those are the only two pairs of numbers that will multiply to give us a -8. Now we need to figure out which pair adds to give us a -2. 1 plus -8 is -7. That doesn't work. 2 plus -4 is -2. That is your pair that works. So then we come over here to the parentheses, and we put the 2 where the plus sign was, and we put the 4 where the minus sign was. And that is a done problem. Let's look at another set together. B. I am looking for two numbers that multiply to give me C, or positive 44, and add to give me B, or positive 15. So I need to multiply to get a positive and add to get a positive. If my multiplying number, C, is positive, my signs are the same. They are either both positive or both negative. Because I have to add to also get a positive, for this problem, everything's positive. So I'm going to go and write down my parentheses, and I'm going to put my X's, and I've just decided that everything's positive. Now I start writing out my possibilities. I'm working with the number 44. Well, 44 could be 1 times 44. 44 could be 2 times 22. Does 3 go into 44? What's 44 divided by 3? Is it a whole number? No. Can 4 go into 44? Yes. 44 divided by 4 is 11. And that are your three options. Those are your three options. So now we're looking for which pair adds up to 15. 1 plus 44 is 45. That doesn't work. 2 plus 22 is 24. That doesn't work. 4 plus 11 is 15. And that's your pair. So I'm going to put a 4 here and an 11 there. Let's look down at C together. You are trying to find two numbers that multiply to give you negative 12 and add to give you, what's the imaginary number here? It's a 1. That's your addition number, is a positive 1. So, because my multiplying number is negative, I have one positive and one negative. Because my adding number is positive, the bigger one is positive. So 2 parentheses with x's, 1 positive, 1 negative. This one's your bigger number. Let's start thinking of some options. Well, 12 is definitely 1 and 12. 12 divided by 2 is 6. 12 divided by 3 is 4. And that's it. And we just decided that the bigger number is positive, so these 3 little guys are negatives. Which pair adds up to a positive 1? Well, if you add negative 1 and 12, you get 11. Negative 2 and 6, you get 4. Negative 3 and 4, oh, there's your 1. So I'm going to put the 3 with the negative and the 4 with the positive. By the way, it doesn't matter which order you put them in, as long as the right signs are with the right numbers. Finally, we're looking for two numbers that multiply to give us a positive 25 and add to give us a negative 10. Well, since our multiplying number is positive, we have either two positives or two negatives. The signs are the same. But because my adding number is negative, they are both negatives. So, parentheses, I have x and two negatives. 25, not a whole lot of options here. We definitely have 1 times 25, but the only other pair of numbers that multiplies to give you 25 is 5 and 5. Both numbers are negative. Which one of those two pairs adds up to give you a negative 10? That would be that pair right there. So negative 5 and a negative 5. Like I said, if you're good at your multiplication facts, these will come pretty easy. So I want you to pause the video, and I want you to turn to example 2 and try these 4 on your own and see how you did with the rules. So let's see how you did. We are multiplying to give you negative 45 and adding to give you 4. And that means we have x and x. One positive, one negative. The bigger one's positive. My pairs were 1 and 45, 3 and 15, and 5 and 9. The bigger one was positive. The only pair that worked out of that set was the bottom one. Negative 5 and positive 9. We are multiplying on B to get a 9 and adding to get a 6. Positive here and a positive here means that they are both positives. My only options for 9 were 1 and 9 or 3 and 3. The pair that makes 6 when you add them up are 3 and 3. We are trying to multiply to get a positive 8, but add to get a negative 6. Because m is positive, the signs are the same. Because a is negative, they are both negatives. Eight, my options are 1 and 8, or 2 and 4, both negatives. The only pair that added up to -6 were those guys, -2 and -4. Finally, multiply to give you 48, add to give you 14. M is positive, A is positive. That means we have two positives. (48) is 1 in 48. 48 divided by 2 is 24. 48 divided by 3 is 16. 48 divided by 4 is 12. And the only other pair that goes into 48 is 6 and 8. Of those 5 pairs, the pair that adds up to 14 are those guys. So how'd you do on those? It's all about knowing your rules and knowing your multiplication facts. So let's look at the next type of problem that's actually easier. Our next type of problem is called the difference of two squares, or you will hear me refer to it as dots, as a simplified way of saying it. So let's write down some rules. Dots problems are very, very special, and they have some very important pieces to them. First of all, they have no B term. That's the part in the middle. So the guy in the middle is gone. The number that is in the problem is what we refer to as a perfect square. Perfect squares are numbers that you can square root and get a really nice number. And so to solve these, we use square roots, and you will always have one positive and one negative. So if you notice, look at all 4 of these problems. All 4 of these are missing that middle part. They have the x squared, they have the number at the end, they don't have the number in the middle. These are examples of dots problems. To solve a dots problem, it is very, very simple. You take the number at the end. In this case, it's 25. We need to find the square root of 25. If you don't know your square roots, you can use a calculator. But the square root of 25 is 5. That's all you need to make your answer. We make our parentheses with our x's. As it says right here, 1 is positive, 1 is negative, and they are both the square root number, which is 5. That's how easy dots problems are. Let's do this one together. The square root of 121. Use your calculator if you need to. It is 11. So I'm going to draw my parentheses with my x's. 1 positive, 1 negative, both of them 11. Pause the video, do the next 2 on your own. Let's see how you did. The square root of 49. Hopefully you guys knew that that was 7. So it's x plus 7 and x minus 7. The square root of 81. Hopefully you knew that that was 9. So it's x plus 9 and x minus 9. Aren't those a nice little shortcut? They're quick, they're easy, can't make any mistakes there. Let's look at the last type of problem for today. It is called a greatest common factor. Now, I know you've heard this in elementary school. Well, maybe not elementary, middle school. You guys in middle school were given 2 numbers, and you were asked to find the biggest number that goes into both of them. For example, in middle school, you might have been told the numbers are 12 and 18. What's the largest number that goes into both of them? And you would sit and you would think, well, 2 goes into both of them, and 3 goes into both of them, but the biggest number that goes into both of them is 6. That's the idea of a greatest common factor. For us, it is, again, the largest, because greatest means largest, but it can be a number, a variable, or both that divide evenly into all terms. Must go in evenly. So let's take a look at example 4 together. Notice the difference in these problems. Okay, these problems, hang on one second, I'm looking at your notes. These are totally different problems. In your notes, this should be 2x squared plus 6x minus 20. I'm sorry. Let's get rid of that. If you notice on these, they start out differently. Every problem we've done so far starts off with x squared. But this is now 2x squared, and this is now negative 3x squared. That's your big red flag that you have a greatest common factor, because we don't want that number at the beginning of our equation. So, if I look at my options here, I have a 2, a 6, and a negative 20. I need a number that I can divide 2, 6, and negative 20 all by evenly. And that number is 2, which happens to be the number in the front. So here's how we do these problems. That number that we just found gets written down. We are now going to make a giant set of parentheses, just one. We're going to take every number in our problem and divide it by 2. 2x squared divided by 2, the 2's cancel, we're left with x squared. Positive 6x divided by 2 is positive 3x. I just divided. And negative 20 divided by 2 is negative 10. That is a new step. However, that 2, if he wasn't there, so I'm going to temporarily put a green box over the top of him. If that 2 wasn't there, okay, what's left there is a problem like we did earlier. So you're going to pretend that 2 doesn't even exist. And you're going to do your A and M stuff like earlier. We are now looking for 2 numbers that multiply to give you negative 10 and add to give you 3. Notice I didn't go back to the original problem. I stayed on the line I'm on. So I need to multiply to get a negative. That means 1 positive and 1 negative. And I need to add to get a positive. That means the bigger one is positive. So parentheses with my x's. 1 positive, 1 negative. This guy is the bigger one. What are my only options for 10? Well, I have 1 and 10 and 2 and 5. And the bigger one is positive, so these little guys are negatives. Which one of these pairs adds up to give you a positive 3? Well, that would be this pair. So I'm going to insert those in the parentheses. Negative 2, positive 5. The only difference between these new problems and the ones from earlier in the lesson is this 2 that I had put a box over is now important. That 2 is there. So we need to take that 2 and just drag it down in front of the parentheses. If you don't put the 2 there, you won't get back to the original problem. It's a requirement to be there. That is the hardest problem you will see today with the extra number. Let's look at another one together. We have negative 3 and positive 27 and negative 54. We need to divide all of these by the GCF. Well, what are all 3 of these numbers divisible by? They are all divisible by the number 3. However, because we want all of this to go away, they're all divisible by negative 3. So I'm going to make negative 3 my GCF. And I'm going to divide every number by negative 3. Well, negative 3 divided by negative 3 goes away. You're left with x squared. Positive 27 divided by negative 3 is negative 9. The x tags along. Negative 54 divided by negative 3 is positive 18. Watch your signs because you don't want to make any mistakes there. Now, we're again going to pretend that that 3 is not there. We are going to look at this and find our A and our M. We're looking for two numbers that multiply to give us 18 and add to give us negative 9. Well, if my multiplying number is positive, that means my signs are the same. If my adding number is negative, it means they are both negatives. Let's look at our options for 18. Well, we have 1 and 18. 18 divided by 2 is 9. And 18 divided by 3 is 6. And that's the last option. And they are all negatives. Which pair, when you add them, gives you negative 9? Well, that pair is negative 19. That pair is negative 11. That pair is negative 9. So I'm going to put the negative 3 there, the negative 6 there, but of course, I need to bring that negative 3 down in front, otherwise the answer is wrong. Okay, so pause the video now. I would like you to try these last 4 problems on your own, and then we will see how you did. Let's take a look. So your GCF should have been the 2. Divide everything by 2, we get x squared plus 8x plus 15. You should have now been looking for two numbers that multiply to give you 15 and add to give you 8. Positive here means both positives. The only options for 15 are 1 and 15 and 3 and 5. The pair that adds up to give you 8 were 3 and 5. Bring down your 2. On B, your GCF should have been that 4 right there. So write down the 4. 4 divided by 4 is x squared. Negative 20 divided by 4 is negative 5x. And negative 56 divided by 4 is negative 14. We are looking for two numbers that multiply to give us negative 14 and add to give us negative 5. Since m is negative, we have one positive, one negative, and the bigger one is negative. One positive, one negative, this one's the bigger one. 14, our only options are 1 and 14. 2 and 7, the bigger one's negative. And the only pair that adds up to give you a negative 5 is that pair right there. Positive 2, negative 7, bring down the 4. This one, your GCF was the negative 5. Divide and we get x squared. Negative 10 divided by negative 5 is positive 2x. Positive 15 divided by negative 5 is negative 3. We are looking for two numbers that multiply to give us negative 3 and add to give us 2. Since the multiplying number is negative, there's one positive, one negative. Since the adding number is positive, the bigger one's positive. One positive, one negative, bigger one's positive. Well, there's only one pair that multiplies to give you 3, and that is 1 and 3, and the bigger one's negative. And yes, those two add up to give you 2. So a -1, +3, bring down the -5. Last question for this little lesson. Your GCF should have been 3. Divide by 3, you get x squared minus 16. Hopefully you stopped here and thought, wait a minute, something looks different. This doesn't look like any of these other guys. What does it look like? Hopefully you said it looked like a dots problem, because it does. Remember those dots problems that we did 2 slides ago? Okay, these guys right here? All of these look just like the one you're looking at. You should have used square roots. We should have said, well, the square root of 16 is 4. So I have an x and an x, 1 positive and 1 negative, because that's part of dots. 4, 4, bring down the 3. And that is the end of your lesson. These are problems that take some practice and take memorizing your rules. So I will see you in class.